Hi, in this video you will learn more about the latest upgrades to our uEye Live camera family. Increasing demands in industrial process monitoring push us to continuously enhance the cameras. We are working on new hardware models with increased robustness and also continuously improving the software, which, as always, is available free of charge. So you can look forward to another model in a factory automation housing in spring 2026. In addition to the two existing cameras, it will be certified to the highest IP protection class, IP69K, and can also be conveniently operated via power over Ethernet with a single cable for data and power supply. With firmware 1.2, we expand the functions of the cameras with additional key features for industrial process monitoring, such as digital pan-tilt zoom, as well as adjustable privacy zones. These smart tools give you even more flexibility and security when it comes to visual process control. So let's take a look at these new features together. Together with firmware 1.2, a new finder tool specifically for uEye Live cameras is also available, providing you with a suitable management tool that makes it easy to integrate IDS monitoring cameras into your own network, set and change IP addresses, and access the web front end of the respective cameras to configure them for your specific application. Here you can see how a camera that is currently being connected is identified in the network and displayed within the finder. It automatically lists all cameras that are accessible via broadcast messaging, even if they may not have a suitable fixed IP address within your subnet. This can be quickly adjusted here by assigning a fixed IP address or switching the camera to DHCP mode, allowing a server to handle the address assignment. The camera is now accessible and the web front end can be opened. And here we already find the first new feature in firmware 1.2. Although the current camera models in the uEye Live camera family uses an 8 megapixel Sony Starvis 2 sensor, their SoC can only stream in Full HD at most. This means that the field of view of the native sensor resolution is scaled to streams with a maximum Full HD resolution. However, a new REST function allows to request still images in native 8 megapixel sensor resolution, here integrated as a button in a web cockpit. The result is an 8 megapixel image of the sensor of the current scene, which can be used for additional image processing tasks, for example. If we take a look at the corresponding REST functions, we can see that there are more settings available for this single image capture. The Get Camera Image function offers parameters for quality, width, height, image source, and even image type, so whether JPEG, PNG, or an uncompressed bitmap. With the integrated Swagger UI, you can try out by executing the REST function directly, and the image is even displayed here. This way you can explore any other camera function and try it out immediately without having to program anything directly. To demonstrate the next new camera function, we had some help from our robot to illustrate more clearly how it can be used. A TM12S robot from Techman will pick up the uEye cameras with a Schunk coax gripper, stack them in a storage location, and then dismantle the whole thing again. This gives me the opportunity to explain how the pan tilt and zoom function works. And also for this function of the graphical user interface, which you can see on the left side of the camera's web front end, there is of course another REST function that allows you to zoom to specific image areas using X, Y, width and height, which are then scaled to the configured stream resolution. With Python, it is very easy to build a small GUI application to use these REST functions. Here, PTZ variables for different image sections can be sent to the camera as payload via the camera PTZ patch command to control the zoom. Triggering the PTZ commands via the Python sample changes the zoom window in the web frontend, which finally leads to zooming of the stream output. In such a robot application, this could be used to monitor different positions from close-up, or it could even be used to implement a digital camera path within the sensor field of view, as you can see here. The last feature I would like to show you is called privacy zones. Here too we will use the robot use case, because there could of course also be monitoring situations where sensitive data is visible in the field of view that should not be published or recorded. As can be seen here, this could be a monitor screen displaying such sensitive data. With the privacy mask feature, you can place up to 10 masks of any size and position in the camera's field of view, which are then blacked out directly in the data path after the sensor, even before this image data becomes visible or is further processed. The contents of these privacy zones are almost non-existent. So if the presettings ensure data protection, as in this case, GDPR-compliant process monitoring can be realized. As you can see, the zones can be set very precisely and conveniently in the web frontend using the mouse. With the new features of firmware update 1.2, you can use IDS monitoring cameras in an even more specific way. And if you already use a uEye Live camera, you can easily update it for free and try out the features for yourself. If you have any questions, please don't hesitate to contact us and take a look at our Vision Channel media library, which constantly grows up with new and helpful content. In this way, see you next time.